The following video will demonstrate how the Apex GTT calibration roll creates a closed-loop control process for Flexo. Firstly, what is process control? In theory, very simple. Repeat what you did today again tomorrow, or produce today in the same way as you did yesterday. These are very simple statements, but as we know, Flexo is more difficult than this. How the GTT gives a closed loop process control in Flexo will be demonstrated in the following videos. Here we have the machine setting up in a normal fashion. This is the Bobst machine at Adair in UK. You take your first design, the machine is setting up and calibrating itself, and we have on screen the cyan is out of specification. You can see that you have red marks on the delta E and the density. Therefore we have a problem, and the color of the green also will be incorrect. There you see the two samples, what it should be and what it is now. So we have to find the solution and the problem for this. The operator takes the calibration roll, which is by the side of the machine. He swaps it for the analogs that was in for the setup. Takes a little bit of time. And in goes the calibration roll. You can see it's half one engraving and half the other engraving. Only takes a few moments to change. And now we begin to set up again. Only a few moments later. Now you see the SpectroLab is checking again the color of the cyan with a green dot, and now it is in specification and correct. All green lights. Therefore, situation one. We've changed the analogs for the calibration roll and the color has come correct. Therefore, the analogs itself was the problem. We also have situation two. Again, the operator is setting up the press, plates are in, as he does for normal everyday production. The Bobst machine already automatically puts pressure and also registration is correct. And we can see on screen again, the cyan is out of specification for delta E and also for density. So we know there is a problem. We don't know if it's yet the analogs or if it's the ink. You see the samples, again, the green is incorrect because the cyan is too low on density. So we take the calibration roll again. The operator quite simply changes it very quickly on this machine. And again, you see the calibration roll, half GTT-S, half GTT-XS. And only a few moments later, we begin production again, or we begin setup. Now we look on screen and we try and find, is it the analogs or is it the ink that is the problem? If we look on this, we have the master and then the proof, showing that we are still light on color density. And if you look at the JPEG, again, the cyan is still making the green color incorrect. Therefore, the analogs has not solved the problem. And we can see here, the density and the delta E are still incorrect. That means when we've changed the analogs, it doesn't become correct. Therefore, the calibration roll we know is true. Therefore, the problem is the ink. And the solution is change the ink pan or change the ink formulation. And we have situation three. Situation three, again, the operator sets up in the normal fashion. He uses the BOPS machine, which automatically puts impression settings and also registration for each unit. And we look on screen to see if everything is correct or there is a problem. When we look on screen, the cyan is okay for density, but it's out on the dot gain, the 50%, which means it's also out on the green. The green color is also a fail. There you see the two samples, what it should be and what it is now. So we have to find the solution and the problem for this. The solution is that the density is correct, 100%. So we know the Anulux is correct. We know the ink is correct. So the fact that the 50% is not correct, that has to be down to a plate repro issue. So we simply change the plate for the correct plate with the correct values, and we begin production again. And what you see now is it's now calibrating the 50%, and the 50% is now back on correct dot gain. We have green lights everywhere again. Therefore, the machine is running and production begins. So we've clearly identified that that problem was with the printing plate. As we have just demonstrated with the videos, this is the first time that within the Flexo process that there is a true calibration method to identify the source of the problems. This enables fixed palette, Pantone simulation to be produced with consistency, efficiency, and very high quality results. So what does GTT bring to the party? It gives consistent dot gain. It gives a predictable result for the repro, so they understand what is going to come out from the print machine. It gives reproducibility for the printer, so from meter 1 through to meter 50,000, we have a consistent ink transfer and therefore a consistent color. It also gives standardization possibilities for the industry and also for individual printers. So we get consistency from plant to plant, also through to country to country. If you require any more information on fixed palette or GTT or any other Apex products, please contact the website.